Welcome back to Infigyan friends. In this video, we have one very interesting question from exponential equations. It is 1 power x over 100 power x minus 1 equal to 10 power x over 10 power x plus 1. And we are going to calculate here real solutions. So let's get started by writing our denominators cannot be equal to 0. So I can write here 100 power x minus 1 can't be 0. So 100 power x cannot be equal to 1. So we will get conclusion x can't be equal to 0. Let me write here x cannot be 0. And second denominator 10 power x cannot be equal to negative 1. As we know, a power x will be always greater than 0 for real x. So it is not possible. So I will not consider x equal to 0 solution. Now 1 power x will be equal to 1 when x belongs to real number. So I can write my equation as 1 over 100 power x minus 1 equal to 10 power x over 10 power x plus 1. Now we can write 100 as 10 square. So 1 over 10 square whole power x minus 1 equal to 10 power x over 10 power x plus 1. Now I will write one law or property from exponents. It is a power b whole power c. We can write a power c whole power b. So I can swap these two powers. So I can write my equation as 1 over 10 power x whole square minus 1. We can write 1 square equal to 10 power x over 10 power x plus 1. Now I can use a square minus b square formula, which will be equal to a plus b times a minus b. So I can write 1 over 10 power x plus 1 times 10 power x minus 1 equal to 10 power x over 10 power x plus 1. Now we can cancel easily 10 power x plus 1 from the denominator, as 10 power x cannot be equal to negative 1. Now it will be 1 over 10 power x minus 1 in LHS and 10 power x in RHS. Now I can cross multiply as x cannot be 0. So I can write 10 power x times 10 power x minus 1 equal to 1. Now let's consider 10 power x equal to a. So a must be always positive. So I can write equation a times a minus 1 equal to 1, or we can write a square minus a equal to 1, a square minus a minus 1 equal to 0. Now this is one quadratic equation. If I will write one general ax square plus bx plus c equal to 0 equation, then we can get solution x using quadratic formula. It will be minus b plus minus the square root of b square minus 4ac over 2a. Let's apply this formula to our quadratic equation. A square minus a minus 1 equal to 0. So I can write a square minus a minus 1 equal to 0. So a will be equal to minus of minus 1, it is minus b, plus minus the square root of b square. So minus 1 is square, minus 4 times 1 times minus 1 over 2 times 1. Further, we can simplify 1 plus minus is square root of 1 plus 4 over 2, or we can write 1 plus minus is square root 5 over 2, or we can write 1 plus root 5 over 2, 1 minus root 5 over 2. Now we know the value of root 5. Root 5 is approximately 2.236. So if I will take away 2.236 from 1, we will get negative value. And condition on A was A should be positive only. So we will reject this value. So 1 plus root 5 over 2, it is positive quantity, so it will be accepted. So we can write here A will be equal to root 5 plus 1 over 2, which is the golden ratio. Let me write here A equal to root 5 plus 1 over 2. This is equal to golden ratio 5. Now we have to solve using log because A was our substitution 10 power x. So I can write here 10 power x equal to root 5 plus 1 over 2. Let us consider log both sides with base 10. So log with base 10, log with base 10. Now I will use one log property. It is log a power b. We can write b log a. So this x will come down as a multiplier. So I can write x log 10 with base 10, and right hand side will be log root 5 plus 1 over 2 with base 10. Now we know that log a with base a, this value is always 1. So I can write here 1. So x will become log root 5 plus 1 over 2 with base 10. Let us solve using log property. I will write x will be equal to log root 5 plus 1 over 2 with base 10. We know the property of log a over b. This will be equal to log a minus log b, which we will apply here. Let's apply. So I can write x will be equal to log root 5 plus 1 minus log 2. Base is 10. Now root 5 is 2.23. So I can write the approximate value of root 5, 2.23 plus 1 minus log 2. So we can write log 3.23 minus log 2. Log 3.23 is 0.509. Log 2 is 0.301. And this difference will give us our answer 0.208. approximately. And this will be our final and correct answer. I hope friends you will like this video. Thank you so very much for watching. Do not forget to like, share and subscribe. Till next video, goodbye.